Hi, in this video, let's try to discuss how to solve this equation and how to write up our work. Solve the equation 2/3 x equals 5. Recall that means we would like to find all numbers x for which this equation is true. So a good starting sentence would be, assume there's a number x that satisfies the equation. So now x is a number. So what this means on the number line is x is some number such that 2/3 x and 5 are exactly the same number or the same point on the number line. Now we discussed in another video that we can multiply both sides of the equation by the same number. What that means on the number line is whatever we multiply this number by, we get a new point on the number line. If we multiply 5 also by the same number, that means that point also moves to the same point. And so we can get to keep the equality sign when we multiply both sides of an equation by the same number. So in this scenario, I would like to multiply both sides of the equation by some same number. What number is a good choice? So let me give you a good choice and then we'll see why I made that choice. Remember, I would like to isolate x by itself, get x by itself on one side. I notice here I have 2/3 times x. By another video, we know that if I were to multiply 2/3 by its reciprocal, then 2/3 times its reciprocal is 1. So notice what I do here. I choose the reciprocal of 2/3, which is 3/2. I multiply both sides of this equation by 3/2 to get it here. Notice I leave the question as is, I rewrite it and I multiply it here. Now, what would that get us? 3/2 times 2/3 we know is 1. So on this side, I now have only x equals, and what I have here is 3/2 times 5, which is now 15/2. So x equals 15/2 is the solution once you have done the check work. Normally check work would go here, but because of the board space, I've put the check work here. This is one way of doing check work, where I start out with the left-hand expression. Here's the left-hand expression, 2/3 x. And for x, I put in the number 15/2. And notice I don't multiply out 2 and 15. Instead, it's nicer to just keep 2 as 2 is. 15, I think ahead of time because of the 3. I think ahead of time and I factor 15 as 5 times 3. And here in the denominator, I have 3 times 2. Now using the cancellation law of fractions, I can cancel the 3 as a common factor. 2 is a common factor. I can cancel those and I'll be left with 5, which is this. And so everything works out. We can see x equals 15/2 does satisfy the equation. So when you have a situation like this, 2/3 times x equals 5, do not convert 2/3 into a decimal. Firstly, if you try to do that, you will not get a finite decimal, and it's not a good practice to convert fractions inside an equation into decimals or mixed numbers. So don't do that. Leave the fractions as they are and deal with them in this manner. There's also a second way we could have handled this equation, and I'll show it to you on the other board. So here's method 2. I write the equation I've been given, and it is a method that's called clearing the fraction or clearing the denominator. I noticed that this would have been an easier equation if I didn't have a fraction like this. So I noticed that if I multiply both sides by 3, I can actually clear the fraction in the following manner. So if I multiply both sides by 3, 3 times 2/3 is simply 2. So this whole expression is 2x, and on this side I have 15. This is an equation without any fractions in it. And now one more step. Here I notice 2x means 2 times x, and so I must now divide both sides by 2. If I do so, then this 2 and this 2 would cancel out by the cancellation law of fractions, and then I would get x here. Here 15 over 2 is 15 over 2, and here x equals 15 over 2. Notice I made the choice of dividing both sides by 2, since 2x divided by 2, if you have this expression, I can use the cancellation law of fraction. We do not subtract 2 from both sides, because if we do that, then we would get 2x minus 2 equals 15 minus 2. 2x minus 2 is not helping us isolate x by itself, whereas dividing by 2 is a good choice in this situation. So I've given you two ways to handle such an equation which has fractions in it. The first way is quicker, shorter if you multiply both sides by the reciprocal of 2/3. However, if you're more comfortable this way, which involves 2 steps, that's also correct. But whatever you do, do not convert 2/3 into a finite decimal. So that's the message. Thank you.